Hey guys, so for this lecture, I'm going to discuss how to find the maximum power transfer out of real sources. This can be done by first finding what resistance would draw such a power out of either a current or a voltage source. Okay, so first of all, every real source has what we call an internal resistance or an output source resistance, as you can see right here for this voltage source and right here for this current source. This is denoted as RS in series with the voltage source like you can see on the left, and RS in parallel with the current source as you can see on the right. If we consider adding a load resistor to our open circuit at its nodes, as I've done right here, it is possible to find the maximum power of the real source, whether it may be a voltage or a current source. However, we first want to find RL, the load resistance connected in the circuit that will draw the maximum source power. So you might be asking, well, how do we know what the load resistance must be to maximize our power? Well, we first know that power is equal to voltage times current for a resistor. If our load resistor is extremely large, like I've drawn right here, meaning that it has a huge resistance, we know that very little current will be flowing through that resistor just based off of the large resistance. And if current is small and P is equal to IV, then our power will be extremely small as well based on this relationship. On the other hand, if the load resistance is very small, meaning the value of its resistance is very small, the voltage drop across the resistor will be very small as well. And if the linear relationship P equals IV holds true, then our power will be very small. So essentially, in order to maximize our power, we need our load resistance to be equal to our source resistance. And this can be seen through the following proof, although you don't necessarily need to know this for an exam or anything. So the power of our load is obviously equal to VL times IL. This is also equal to RL times IL squared. And this is equivalent to RL times VS over RS plus RL squared. Now, in order to maximize our power, we have to take the derivative of that relationship and set it equal to 0. So anyways, this is also equal to VS over RS plus RL squared plus 2R load times VS over RS plus RL times negative VS over RS plus RL squared. Essentially, when you solve for RS and RL, you find that RS is equal to RL. And this is key in order to find, this is extremely important when needing to find P max. So knowing that R of the load must equal to R of the source to consume maximum power, we can see that the maximum power of the load, so P max, has to be equal to RS times VS squared over 4RS squared. You can cancel out this RS and this squared value, and you find that P max is equal to V source over 4RS, just 4RS. This equation, this relationship right here, is what you will use to find max power transferred. Okay, so now let's do an example similar to what you may have seen in some homework problems. Okay, so we're given a circuit here, and the example asks us to find R load for maximum power transfer and then to find the maximum power transferred. So in order to find RL, step 1 is to find the Thevenin equivalent of the circuit, where we short circuit all voltage sources and open up all current sources. So you can see we have a voltage source here and a current source here. So step 1, let's rewrite this circuit. There's our short-circuited voltage source and our opened up current source with all the same resistors. our load, and then I'll just write, for the sake of time, 6, 3, 1. Now we can analyze these resistors and say, okay, these two are obviously in parallel, and once we find the parallel equivalent resistance of these two in parallel, we can sum up that resistance with this 6 kilo ohm resistor and find an equivalent source resistance. So first we find that the equivalent resistance for this right here is going to be 0.75 kilo ohms, and then we still have this 6 kilo ohm resistor right here. We have our load resistor connected right there in our open nodes, and like I said before, these are in series. Oops. These are in series, so this is equivalent to a 6.75 kilo ohm resistor. So essentially, this 6.5 kilo ohm resistor is our R Thevenin, and our R Thevenin is equal to our R source, which for maximum power must also equal to our R load. So 6.75 kilo ohms is our RL. That's part A. Now for part B, the question asks us to find maximum power of the circuit, which I've redrawn here. In order to do this, we need to find V Thevenin of the circuit and apply the equation P max is equal to Vs squared over 4Rs. Remember, we found 4Rs in the previous equation. We found Rs in the previous equation, which is also equal to RL. So I'll rewrite Rs is equal to 6.75 kilo ohms. Okay, so looking at the circuit, this is the same as the one I drew before. We can find V Thevenin by looking at this right here and this right here and saying, okay, we can definitely do a source transformation of these two, this voltage source and this current source. If we equivalate another circuit to this, we have, doing a source transformation right there, we have a 24 milliamp current source in parallel with a 1 kilo ohm resistor. We still have this right here, this 3 kilo ohm resistor. And then, of course, doing a source transformation of this current source and this resistor, we have a 12 volt resistor source, a 12 volt voltage source, and again, a 6 kilo ohm resistor. And we have our load resistor. Okay, so these two resistors are connected in parallel. So we can say that this current source is again in parallel with the 0.75 kilo ohm resistor. And just reiterating here, and we can do one more source transformation to get all voltage sources and to find the V Thevenin of this circuit. We can go over here and say that we have our 12 voltage source, 12 volt voltage source, a resistor, and a voltage source in parallel. Finding the equivalent voltage of these two gets us an 18 volt resistor, an 18 volt voltage source, and that, and our open nodes. From here we can sum up these two things and find our V Thevenin to equal 30 volts. After all of this work, we still know that P max is equal to Vs squared over 4Rs, which is equal to 30 squared divided by 4 times 6.75, our RS that we found in part A. And all of this is equal to 33.33 milliwatts. So that gives us our answer for part B. I hope my example problem was useful and that you found my lecture to be somewhat helpful. Thanks guys, bye.